If you're looking for news and interviews related to the conference Civo Navigate, then this episode is for you. Welcome to Is It Observable? Today's episode is a bit special. I won't present any framework or solution providing value to our observability. Today, I want to share with you the atmosphere and the experience of the conference Civo Navigate. During that conference, I had the chance to present, but also I met several speakers that are also presenting. Lots of great names of the industry, so Viktor Farcic, David Flanagan, and more. So if you want to learn more, I have lots of interviews of those speakers, so follow me. We're going to travel to Florida.
My name is David Flanagan, although most people know me as RawCode on Twitter, YouTube, GitHub, etc. I'm a Kubernetes contributor, Kubernetes educator, building out my YouTube channel, the RawCode Academy, and I spent the last 6 years doing DevRel for cloud-native open source companies.
So tell us more about RawCode. So how did you start? When did you start the adventure? What topics are you mainly cover? And do you have any also announcement or anything that you want to share about RawCode?
Sweet, there's a lot there. So the RawCode Academy started in 2020. I was working for InfluxDB, the time series database company. And in 2019, I did 42 conferences. 42. It's almost one a week.
Oh.
And I was not hating life, but I was getting pretty burnt out. And I thought, I need to find another way to share my knowledge with people. And I started exploring YouTube. So at the start of 2020, I started putting out a few videos, seeing how things went, and then COVID hit. And then I had no choice. I was like, all right, I guess we're going full time on video. And then I think over the last, from 2020 to 2021, I did 100 videos. All terrible. Absolutely terrible, but you've got to start somewhere, and I just started getting hopefully better and better, and now we are 3 years into that YouTube journey. 250 videos. I've had maintainers from almost every cloud native landscape project that there is, and that sandbox keeps growing, so I'm not going to run out of any projects anytime soon, and the plan is just to keep producing content that helps people learn these really hard things. You know, we've got a lot of people coming into the Kubernetes and cloud native ecosystem. They're not sure what that path is. The learning journey for cloud native is very complex. People need to learn containers, they have to learn microservices, they have to learn service mesh, monitoring, pushing into observability, backups and restore. All of this stuff is a lot harder when Kubernetes is the platform. And I want to help people with that. So that's my mission.
So you were here at Civo Navigate, and you were presenting. Could you tell us a bit more about your presentation?
Yeah, it's my second favorite talk ever that I love to give, because I started off with a 3-minute video of just me failing miserably and fixing a Kubernetes cluster. And the whole point of the talk is not to teach people anything about Kubernetes or about cloud native or eBPF, although I do try to do a little bit of that. The core sentiment behind the talk is to normalize saying, I don't know. I feel we have a very strong hero culture in technology that we need to just kind of get rid of. We reward people that come swooping in and save projects at the last minute with their infinite wisdom brain, but nobody has an infinite wisdom brain. We all learn through failure, and we have to normalize saying I don't know, normalize saying I made a mistake, and just build a community, an ecosystem, a environment where people feel safe to learn the hard way.
So I'm Frederik. I founded the company called Polar Signals. I've been working in and around the open source, cloud native observability space for the last 8 years now. I'm part of the Prometheus team. For a long time, I was the technical lead for the special interest group for instrumentation in the Kubernetes project. So, everything in the observability space, and especially that connecting Prometheus and Kubernetes, I've probably touched pretty much everything at this point.
And also, by the way, for those who are using the Prometheus operator, I think lots of features that are very useful for us comes from your ideas, no?
That's right. I'm actually one of the creators of the Prometheus operator project. Yeah.
Cool. So, what about Polar Signals? So, what do you do? What is your project, open source project behind Polar Signals?
Yeah. So, at Polar Signals, we do continuous profiling. So, for those who are maybe unfamiliar, maybe you're familiar with profiling, where with profiling we look at let's say a process for a very short period of time, let's say 10 seconds, and look at it very often during that time frame. So let's say 10,000 times per second, right? That's the sampling rate. And so doing that, we can figure out where is the CPU time spent in our process. And the thing that traditionally profiling has associated with it is that it adds a lot of overhead. And indeed, when we look at it 10,000 times a second, we do add a lot of overhead. And so kind of the core idea of continuous profiling is we sample this data at a very low frequency. For example, our open source project, Parka, does this at 19 hertz, and we can talk about the number 19 in a second a little bit more. But compared to 10,000 hertz, that's a very, very small number. But the difference is we gather that same statistical significance over a long period of time while adding very low amount of overhead, right? So we can still get that same confidence about our process and where CPU time is spent in our process without having that impact on our production workloads.
And so there are several solutions out there doing profiling where you have to add like an agent where you basically initialize the profiler, and then you can have the options similar to pprof. You can tag the profile to that. Is Parka doing the same approach, or are you doing it differently?
So actually, Parka at its core integrates very strongly around the pprof format. So it supports everything that the pprof format can do. It can do profiling labels. So for example, you can tag specific stack traces with whatever is useful to you. It can be a customer, so that you can understand which customer is using CPU time within your system or something like that. But it's just labels, right? You can make it whatever you want to. And Parka does allow you to write labels to Parka as well. So you can arbitrarily distinguish stack traces.
Okay. And in a Kubernetes environment, do I need to touch my code, or you have a secret sauce that will get profile out of the box?
So I think this is something where some of what we do is pretty unique. So we use eBPF, and this part is not really unique anymore. But using eBPF, we can grab this data with zero instrumentation from your entire infrastructure. And partly why we're using eBPF is to further reduce the overhead that this is going to have on your workload. But especially comparing to workloads, to profilers like those built into the Go runtime, or pretty much every other application profiler out there works the same way. We don't use something called sigprof, which actually alters the flow of your program. And so the problem with some profilers is if you use them all the time on your production infrastructure, you may actually permanently altering the flow of your code. Whereas with eBPF, that doesn't happen. We're able to capture the data essentially from within the Linux kernel, not stopping the world, which is very much generalizing, but pretty much what sigprof does. So we can actually capture much more genuinely what your code does.
So you just talked today. So what was the topic of your presentation?
It was about shifting left stuff, like database, application, clusters, enabling developers to do things by themselves by creating services that they can consume.
So basically trying to let the developers configuring their own infrastructure?
Yeah, infrastructure services, everything. So think of it this way. What is AWS to an operator is what operator should create for everybody else.
Okay.
In a way, but tailor-made to their needs. Because when you think about it, AWS are building blocks, right? They are not really something that is usable for people who are not very experienced with AWS, right? So how can we transform that experience and tailor-made it for the needs of people working in a company, right?
So basically, you're maybe also referring to the fact that how can I easily build my own dashboard and observability layers from a code perspective without needing to open a UI and do stuff like this?
Yeah, I mean, it's not that much whether you open a UI or no. It can be a UI, it could be IDE, it could be CLI. It's more like what matters to me, right? Because when you think about it, if we want to enable people to do stuff, we cannot expect them to use the tools that others are using. I cannot spend as a developer, Node.js developer, let's say, or Python developer, doesn't matter who I am. I cannot stop doing what I'm doing and spend 1 year learning Terraform or 2 years learning AWS, right? How can I do everything I need to do?
And still take valuable assets for the
Exactly.
Yeah, makes sense. So, what is the secret sauce for that? Do you have also a solution for that, or?
Yeah, so in my case, it's crossplane. That's what we are trying to do with crossplane compositions. But in reality, it's a combination of tools, right? I'm more focused. So yes, get crossplane. Crossplane is absolutely awesome, right? But I'm more concerned about shifting the mentality of people and saying, instead of waiting for somebody to open a Jira ticket and say, do this for me, I don't want to do anything for anybody. I want to spend my time creating a service so that everybody can consume those services themselves. In my case, that's crossplane. Some other case, it can be something else. We need first to pass that bridge to say, hey, you're a service provider, not the person who reacts to somebody else's requests.
But I guess it happens sometimes that from a development perspective, you don't have the necessary knowledge to come up to the right settings for that. So are you suggesting that we have to build templates of assets so then people can rely on that and easily build what they expect?
Yes, I mean, think of it this way, right? You need to figure out what people need, right? You need to treat other people in a company as your customers, right? And the end result will differ greatly from one company to another. You can say, hey, in this company, for my company, developers are really concerned about those 3 things. And I'm going to enable them to specify those 3 things, and 57,000 other things are going to happen automatically. Some other team or some other company would have completely different needs because people are on different levels of experience doing something, right? So to me, it's similar like, let's say Amazon shopping, right? You don't want to send an email to Amazon and say, ship it to me.
Yeah.
But on the other hand, you don't want to go into details. Is it going to go by air or train or boat? So you need to figure out what is the requirement, what is the level of control somebody wants to have and not more, right? And the level of control that you will have differs. Like for you, for example, it might be that you want to pick a specific version of Kubernetes you want to run. For somebody else, it would be, I don't care, anything you want, right? So it's very important to have that process where you actually figure out what people need and create a service that accomplishes that need.
So my name is Barret Chambers. I'm the Director of Solutions Engineering at Percona. So I work with our customers and potential customers around Percona's products and services. So a lot of background there. I've been there 7 years, so happy to talk about that.
So for those who never heard about Percona, I guess if you are using a database, you know what it is, but could you remind to everyone what type of support you provide and what type of technology that you're getting to the community?
Yeah, sure. So Percona stands for, at least when it was founded, Performance Consultants. So they smash those two words together. Our founders come from MySQL AB. So we've always been in the open source space, specifically around MySQL to start, and then we branched off into MongoDB and Postgres as well. So we have a suite of software as well as services around those three open source database technologies.
And so I was a few minutes ago. You had a talk here at Civo Navigate, which was very interesting. So could you maybe share a few details about it?
Sure. Yeah. So during the talk, I have a background in DevOps, so I know there's a lot of finger pointing when a slowdown occurs within a database environment. So I was discussing kind of when you're seeing those slowdowns, what you need to be considering. So part of that is the query side, and then part of that is the resourcing side. And our support team and consulting teams understand this as well. So we've built a product to kind of help them do their jobs better. And it's an open source product, so everybody can use it. It's called Percona Monitoring and Management. So I was showcasing how you can find those query analytics within that product to kind of diagnose those slowly running queries.
So PMM, so it's the acronym for your solution.
Yeah.
When I looked at your presentation, so first of all, I saw that you were relying on lots of various observability solutions out the market. So
Yes.
I saw on the slide there was the Node exporter, there was the MongoDB exporter, there was the Postgres SQL exporters, and you picked as a storage different solutions. So Grafana for visualizing, Viktor and Matrix. So I thought it was a smart move to be able to have less problems in terms of scalability of the data.
Yes.
So when I looked at the UI of PM, I said, oh, it's Grafana, but there are a couple of things that's been adjusted. So did you fork and change the UI to make it happen, or how did you do that?
I don't know if we forked the UI. I'm not a developer, but I do know that we have selected the various components for, as you said, for like scalability reasons. I mean, and what I would say to that is like learn from our, I guess, mistakes, our learning curve. We made these changes for a reason, right? And it's for performance and scalability for our customers. So while these are all open source products, you can use them yourself, so you can build from scratch if you want. And there are other options for like time series metrics, but we've selected these specifically for their scalability and performance.
So what I really liked about the various UI that you showed us, first, what I thought was really important is there was a list of all the queries that has been happening in the database, and you were showing some diagrams about the usage, the number of calls, lots of very meaningful and useful information, especially when you need to point out what you should optimize. So I thought it was really cool. So what is the required settings for our users to take advantage of PLM?
Yeah, so we do have documentation for each separate database technology. You do require advanced logging. So like on the MySQL side, that would be like performance schema enabled. That does come with a little bit of a performance hit on your databases. So you need to test that and make sure that turning that on is not going to bring your database to a crawl. It should only be like 2 to 5% performance hit across the board. But in the talk, somebody brought that up, and I was like, there's a trade-off, right? You need to see what's going on to diagnose those issues. Maybe you find a slow-performing query that gives you 10% increased performance, and you took a little bit of a hit to turn on those additional diagnostics.
I'm Carl Montanari. I'm a developer at Loft Labs. Mostly working on Loft, our commercial product, but a little bit on vCluster and DevSpace as well. Way back when was a network person and kind of changed into the Kubernetes space and Go and all of that.
So you mentioned vCluster and Loft. Could you tell us a bit more what it is, what it resolves, what's the value of vCluster?
Yeah, absolutely. So vCluster, kind of as the name implies, virtual Kubernetes clusters. I kind of hate the term sometimes because it is a real Kubernetes distribution. When you deploy a vCluster, you're deploying a real Kubernetes API server. By default, that's K3s, but it could be K0s or Kates, like vanilla Kates, or also even EKS. And kind of the super Cliff Notes version of why you would care is namespace isolation is really not isolation. It's like putting things in a namespace. That's obviously not isolation. And full-blown cluster isolation is obviously very expensive because you're paying for control plane at every cloud, or even if you're doing it yourself, you're still paying in terms of effort for managing all of those control planes. So vCluster kind of strikes a nice balance where you can say, hey, I've got this cluster already running. I would like to give some development team or whatever team access to a full cluster. Let me do that inside of this other cluster by deploying this API service or server. And then you can give those teams access to that vCluster, and to them it's a full cluster because it is a full-blown Kubernetes distribution.
But for example, if I deploy an operator on the cluster, would that operator will also run in the vCluster?
So it depends a little bit, of course. That's always the answer. There's a recent addition to vCluster 0.14, generic CRD syncer. So there's ways to sync resources in. By default, we sync things like ingresses and stuff like that. So if you deploy Nginx ingress in your host cluster and you enable that syncing, it's available to you in the vCluster. So if you say, hey, here's my pod in the vCluster, in the virtual cluster, here's a service and here's an ingress, whatever, use the Nginx ingress. It can, again, if you enable it, you can use that ingress controller from the host cluster. So a little bit of it depends, of course, but for the kind of really common use cases, it basically just works out of the box.
So in my chat, we do talk mainly about observability in my channel.
Sure.
And I was wondering, if I start, for example, to deploy, Node Explorer is different because it's on a node, but
sure.
If I use kubestep metrics, would I have also the updates on the various pod or stateful set or deployment or whatever the object I'm creating in the vCluster as well?
Yeah, absolutely. So the simplest case here is, or I guess I should back up a little bit. The virtual cluster being virtual doesn't have a scheduler. So we rely on the scheduler of the host cluster. So when you create, I'll say real, air quotes, because I don't know what else to say there, real instance like a pod or a stateful set that obviously deploys a pod, the pods get deployed and scheduled with the host scheduler and the host cluster. So they look like and they feel like, because they are real pods running in the host cluster. So any kind of visibility that you have in the host cluster, you basically also get that to the vCluster. It just happens to look like a pod that runs in the host cluster.
Okay.
That said, you can also deploy things like a metric server inside of a virtual cluster and get kind of things from that perspective if you're interested. But I think probably, and obviously there's no one size fits all, but probably a lot of folks are relying on whatever observability stuff they have in the host cluster just because they already get that. It's for free. You don't have to add it or do anything to the vCluster.
Of course. Hey everyone, Matt. I'm on the solution team at EdgeDelta, Director of Field Engineering, here enjoying the lovely, beautiful weather in Tampa at the Civo Navigate conference.
So can you tell us more about what your product is doing, what is Resolve, how it fits in the observability world?
I think across the board, we see at a lot of organizations significant struggle to understand what observability data is interesting to them. There's a lot of different ways to approach how that data is actually used. At EdgeDelta, we kind of take a distributed approach. We analyze the data at the source. We want to know more about how someone is using their log data as it occurs, and then make some intelligent decisions about what downstream systems would consume that data and make appropriate routing decisions.
And so you said you're upstream, so it means you are way before, just after the application. So could you explain a bit more like a use case or how does it work in general?
Of course, yeah. I think the edge in EdgeDelta really is very variable depending on where we talk to. So for most customers, that means wherever their data is being produced at the app layer. That could be on a Kubernetes cluster or on a virtual machine, in a function or in an IoT device. So when we say edge, that's what we mean. In the Kubernetes world, it would be an agent that's deployed as a data set.
Okay. And so if, for example, I'm producing OpenTelemetry traces or metrics, how would you capture that? And what would be basically the interaction that you will have with the various open telemetry components, like the collector, for example, and then the observability backend at the end.
I think the idea for us and the typical architecture that we see is for any data set being produced by OpenTelemetry, we'll listen for data being created from that particular system. So we support, for example, OTLP to be able to consume and understand, ingest any log data being created by OpenTelemetry exporters, and then certainly, depending on the architecture of that individual organization, we might route that data to a collector. We might route it right to their eventual observability vendor of choice. Kind of depends on the scenario, but the key is to optimize that data that we do send.
So when you mean optimizing data, so basically, if I have a trace coming in, let's say thousands of times in a given minute, are you basically already processing and then you're sending less data to the backend? This is what you're doing? Same thing for metrics and logs?
So for the most part, I think we focus a little more on log data than traces, although we do support traces in the OpenTelemetry world. But it's the idea of taking an event that may occur once, it may occur twice, it may occur millions of times for a given application, clustering similar events together based on understanding the structure of that event, and then routing the invocations of that to a downstream destination. So I can map out maybe how many times a particular event might occur, but not necessarily losing the sentient details or the variables that happen to make that event unique. So if there are particular points of interest for the teams, convert them over into metrics, route that metrics data downstream. So we're not just paying to send all the data to a destination for the sake of housing all that data.
Okay, so at the end, if I'm a user that will basically manage my data in Prometheus or in, I don't know, a managed tempo for traces, at the end, I will reduce the storage of the measurements due to the processing of your solution.
Reducing storage and hopefully making your life a little easier and a little more efficient. If there's particular traces that are interesting and you want to view the associated log data related to that trace, great. Just only send that log data that you want to take a look at. If you're not going to consume it in a raw format, you probably don't need to store it in expensive storage.
So here at Civo Navigate, what did you, I think you had a session yesterday.
I did. I had a session yesterday and today. So got to talk about Linkerd, show folks some secure practices, and today I got to show off multi-cluster failover, which is exciting.
Okay, so could you talk a bit more about it, more details?
Yeah, so yesterday we were doing a workshop on how to use policy with Linkerd so that you can decide what workloads should be allowed to talk to what in your cluster. We specifically showed how to isolate a namespace in a relatively easy fashion. We also showed a little bit about how to use Cert Manager to do certificate rotation so that each cluster had an intermediary certificate that lasted under 2 days. That was exciting.
So when you do multi-cluster, is like the second cluster becomes like sort of in the same network, Kubernetes network? So I can easily reach out to a service that are sitting in another namespace in the other cluster?
Yeah, so great question. So the way it works is essentially we use the service mesh to make it look like they're all in the same logical space, but you don't have any like network requirements, right? So the way the failover demo works is you have a empty service in the front, which points 100% of its traffic to a local service that points to local instances. And when those local instances become available, that top level service switches over and points you to the remote. So it looks seamless, right? And all of your services never, there's no behavior change. You don't know that you're going multi-cluster. You don't know that you're using the service mesh, right? Like your traffic just shifts to the remote endpoint.
And so if I do that type of configuration, if I do, for example, a non-suitable configuration, I could have some surprises. So is there like a approach where you should look at chaos engineering or testing where you destroy the service and then you figure out if the traffic will be properly routed to the new cluster?
Yeah, so just for anybody out there, chaos engineering or doing stuff to regularly restart and roll your workloads is crazy important. And there's some really good, I don't know if that Kubernetes failure stories websites around, but if you look at incident reports that people have in Kubernetes, a lot of it comes from, hey, I left this thing running too long, made a change a week ago and didn't see that change come into effect. So long story short, yes, absolutely, you should do it. And it's great to do with the failover operator because then you can see it behaving the way you want it to behave.
And yesterday you had a workshop. So this workshop was related to that topic, or was it something else?
It was all on certificate rotation and management, as well as using policy and Linkerd to isolate workloads, right? So when you have a service mesh, you get mutual TLS between your pods. What that means, right, is that both sides of your conversation are positively identified and the traffic's encrypted. So you can use that identity, that certificate, cryptographic identity for your workload to decide should you be allowed to make this call. Right, so you get service-to-service authorization, which is really powerful. So yesterday was about showing all the certificate stuff and then how to take advantage of that to limit who's talking to whom in your cluster.
My name is Marino Wijay. I'm a platform/developer advocate at Solo, and I'm really enjoying Civo Navigate. Happy to be here.
First of all, did you present any topic during Civo Navigate?
Yes, I did. I actually I did two things. I was a co-host for day one of Civo Navigate, so I was introducing a lot of people to the stage. Just bringing a lot of the energy to the audience so that we can really truly enjoy what Civo Navigate has to offer. But I also delivered a talk on edge computing with Kubernetes and Service Mesh.
Cool. So Service Mesh, do you have any, I guess Solo.io is mainly relying on Istio?
Yeah, that's correct. So Solo focuses on developing on top of and even adding and contributing to the Istio project, primarily because it's the most complete, most featurific service mesh out there, and it's widely used. And
so we are in this channel talking mainly about observability, and I've been also doing lots of exercises with Istio and you can read it also. But one project that bring my attention was the Bumblebee project. So could you share a bit about Bumblebee?
Yeah, so Bumblebee was a little open source project created by Solo. And the project really aimed to simplify the experience of building eBPF-based programs. Now, what is eBPF? It's a sandbox mechanism to be able to create these small just-in-time runtime programs that live in the kernel space. So you wouldn't have to recompile the kernel every single time you wanted to add functionality. You would instead write a program that is sandboxed, that is verified by a compiler to make sure that it's not going to crash the kernel or anything like that, but will still allow you to extend your kernel's functionality. So, perfect example. If you've ever used something like TCP dump, that's where eBPF is used, or BPF more specifically. Now, Bumblebee actually helps you write these programs, because when you think about the different ways you can write eBPF programs, eBPF looks at what we call system calls as well as various events that occur in the kernel space. Based off of those events that occur, we'll act on it, we'll do something. And so that something is something we have to build. We have to build that application, but it becomes very difficult because there are a few models in which you can build these apps. You can use the BCC model where you're having to use Python as well as C to create your application, but that's actually cumbersome because now you're having to use two separate languages and you have to compile it and run it every single time. Whereas another model, the libbpf model, allows you to compile once and run anywhere, pretty much like the Docker-like experience. So with the help of libbpf and with all the use cases you can see under the BCC compiler collection or the BPF compiler collection, there are so many use cases we can build tools upon, and we wanted to help with that with Bumblebee. So what Bumblebee did was we'll simplify, give you the structure for your kernel code so that all you need to do is write just the portions of your user space code that you need, and then you'll be on your way to creating an eBPF-based program. You can also mess around and create some kernel-based programs as you need to. Bumblebee simplifies the process because it gives you the skeleton. All you're doing is feeding it the additional bits that you need to make sure that it's looking for the trace points or the hook points or any sort of events that you're looking for.
Okay, and so because initially I thought that there was also a way of providing to the community a sort of a Docker-like approach of BPF, where you can reuse components and avoid reinventing again, building your own BPF code again.
Exactly, and that's exactly what Bumblebee does. So it helps you initialize it by creating the application or whatever program you're creating in eBPF. But it also allows you to ship it off to a container registry. And so it can be OCI compliant. That means as long as you have access to that registry, you know the destination, you can pull it down just like a container artifact you normally would run on your local system or on Docker, for example. Now, in the case of eBPF-based programs, you're pulling down an actual executable that you run locally on your system when you need to run it. So the idea and premise of Bumblebee is build, run, and ship.
That's it for today's episode related to Civo Navigate. It was in fact the first Civo user conference in a really great location in Tampa, really well organized, lots of great speakers, lots of great content, so I really recommend for those who didn't have the chance to come for this edition to come for the next one. As you saw, I had the chance to meet Viktor, Farcic, David Flanagan, Jason Morgan, and many other great speakers presenting lots of great interesting topics related to Kubernetes and, of course, related to observability. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.